This is part 10 of the Craftsman Emerson Gen 2 Drill Press Rebuild series. If you haven't seen part 9, click the link at the top of the screen. In this video, we will be checking the runout on the spindle, cleaning up panels, doing some minor modification, and a little bit of fabrication. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. So the first thing we're going to be doing is checking the runout on this spindle. So we have the spindle chucked inside my metal lathe, which has essentially no runout. And the chuck jaws are clamped onto the spindle right where the bottom bearing would sit. And I've got a dial indicator here that I'm going to set up on the taper. And we'll zero it out. And I should mention that I have a video on runout, and I'll put a link for it at the top of the screen here. But we're basically just going to rotate the chuck by hand. And as you can see, there is almost no runout. That is really good. So now we're just going to reposition the dial indicator a little bit further up on the taper. And we're going to check it again. And I do this on every drill press I rebuild, but I don't always show it on camera. So this is you getting to see it. And once we got it zeroed out, we'll rotate the chuck just like we did previously. And as you can see, in both places, we were less than 1/1000th of an inch. So very good run out on this spindle. We'll check the run out again once we've reassembled the entire drill press. So next what we're going to do is clean up this front trim panel. So I'm going to be using this Meguiar's cleaner wax. And there's some rust that's kind of, I don't know, worked its way in on the edges. And that's not really coming off, but the rest of the panel cleaned up really well. I'm pretty happy with that. All right, next we've got the model number panel. And we're just going to clean that up as well. So in some of my older videos, I told people to let this stuff sit for 15 minutes and then buff it off. And one of my viewers let me know later on that no, you don't need to wait that 15 minutes. You can just start buffing immediately. And this is the data panel off of the motor. And all these panels cleaned up really good. So this is the end cap for the belt cover, and that is the spindle cap for the belt cover. I'm just cleaning them up in some water with a little bit of soap and a toothbrush, trying to get the gross dirt off of them. Then we'll rinse them off, and then we'll hit them with some of that Meguiar's. There's a little bit, I can't tell if that is a scratch or if it's something that's actually on the plexiglass. So we'll find out here. So the way that the speeds are written on that plexiglass is the letters, all the letters and numbers are engraved into that plexiglass on the back side, and then they're filled in with a white paint. This cleaner will not remove that, so you're safe to use it. But that's why we didn't soak them in the simple green. That one turned out pretty good. And we've got the spindle cap. It cleaned up pretty good as well. Just going to do some final cleaning with some Q-tips. All right, next we're going to be modifying the switch mounting panel or mounting plate. So these are the toggle switches I'm going to use, and they're almost an exact replica of the original. I ordered these off of Amazon, and I'll put a link for them in the description if anybody wants to buy some. So what I'm going to be doing is I'm going to add a second switch to this panel. And then when I rewire it, I'll have a switch to turn the motor on, and then I'll have a switch to turn the light on. So I can turn the light on separately. So once we've got it all mapped out there, we can go ahead and drill 4 holes in it. And it doesn't have to be 100% accurate, because the switch itself has a lip that overhangs by about 1/16 of an inch, maybe 1/8 of an inch at most. If we go a little big, it's not the end of the world. So now we're just going to connect those circle or holes that we drilled. So we're connecting the dots with this cut-out foil on a Dremel or on a Fordham to remove that center piece. And then once we've got it out of there, we can clean up that hole with a file and get everything nice and square, get all the burrs off of it. And then we'll take it back over to the workbench, and we're going to test fit that switch to make sure it drops in there and snaps in place like it's supposed to. Looks pretty good. And then we just need to compress those metal clips to get the switch back out of there. Now we're going to clean up the panel. This is aluminum, and the original finish from the factory is kind of a brushed finish. But the more I thought about it, the more I decided I wanted to try to polish it, which worked okay. It didn't come out like I wanted it to, but you know, it is what it is. So to do that, we needed to dry sand it, starting with 100 grit. And we sanded it with the 100, and then the 180, and the 220, and the 320. And then we wet sanded with 400, 600, 800, and 1,000. And we rinsed between each grit. So I've had to strip the chrome off of parts before and then polish them, you know, get them down to their bare metal and then polish them, sand them, wet sand them, and then polish them. And the process is pretty much the same for all of that, whether you're removing the chrome or just trying to polish the aluminum. Anyway, for the panel, all we did was finish cleaning it off, and then we applied the Mother's Mag and aluminum polish to it. And we're going to take it over to the buffing wheel and see if it'll polish up. And if you do this, you're going to keep pretty good hand on that panel, because with those cutouts in it, that buffing wheel wants to snag it out of your hand. And it did polish up, but it also gets really hot, and that polishing compound, you can see some of it still on there. It's the black specks. So you can see there's a really good reflection on it, but that polishing compound is on there. I could spend some more time on it and get the whole thing looking like a mirror, but it's good enough for what I wanted it to look like. So after we cleaned it up, then we went ahead and coated it with the super slick stuff. Then we wiped it down with a rag and set it aside. So if you remember from disassembly, the way that the belt cover was mounted to the guard plate, there were two small screws with two nuts on them. And I've talked to my good friend Frank Lee, and he's advised me that he's actually seen 3 different ways that these are mounted. And one of them was with the screws, one of them was with these little bitty inserts on screws, and then the third method, which is what I prefer, which is the use of the pivot shaft. And so I'm going to fabricate a pivot shaft for this drill press. So I've got a piece of 1/4-inch steel that I'm now cutting at roughly 7 inches. The space between the guard itself is 6 inches, so we'll figure 1/2 inch of thread on each end. So we're just going to cut this rod, and then we're going to thread it with 1/4-20 thread. So after we've got it cut, we'll just clean up the ends. Like so. Love that sander. Then we're going to use the lathe, and we're going to turn down each 1/2 inch on each end to 7/32. So we should be able to do this in one pass. And we'll just get some oil on there. And away we go. And we'll just do a check and make sure that we're at the proper diameter. Yep. So we'll just flip the rod over and do the exact same thing on this end. And I am by no means a machinist. My knowledge on how to operate my lathe is very limited. I have done threading with it before, but it's also horribly inaccurate because this is some communist Chinese junk. And until I get a proper lathe, I'm not going to be doing any threading on the lathe. So we'll be threading this by hand once we get it turned down. Part of the problem is with these small lathes, like the one I have, is anytime you're trying to thread something that's serious, like a barrel off of a rifle or something, you have to do it in multiple passes because this lathe can't handle serious threading like that. So yeah, it is one big headache. So in the meantime, we'll thread this little bitty rod with 1/4x20 thread by hand. And it's not the best method, obviously, but it works. Once we've got one end threaded, we'll make sure we're threaded all the way down to where we took this down, so 1/2 inch down. And then we'll flip the rod over and do the other side as well. We'll test and make sure that the wing nuts are going to thread on there with no issues. And we'll come back and chamfer all of that in a minute. So, stick it back inside the lathe. And we're just going to chamfer it with a file. Just chamfer that lip and then chamfer the end of the thread. Too easy. And we're just going to go ahead and polish this rod. So while we've got it where we've got it, we'll dry sand. We're going to use, I think that's 180, and then 220, and then 320. And then we'll wet sand. There's 400, 600, 800, and 1,000. Be sure to wrench between each grit. And then we'll apply that mother's mag and aluminum polish to it. And then we'll buff it. And we'll flip it over and re-chamfer the other end. And then dry sand the other end. And then wet sand the other end. And then polish the other end. And now we have a working pivot shaft. And really the only thing left to do, since this is raw metal, raw steel, is we'll just pull it out of the chuck here, and then we'll coat it with some super slick stuff and wipe it down. And that is going to wrap up this video. Hope you enjoyed it. If you did, please like and subscribe. In the next video, we will be assembling the motor and possibly more. But that's the goal, is to assemble the motor in the next video. So we're probably looking at 2 videos left in this series, unless something crazy happens. So if you got any questions or comments, leave them in the comments section below. I'll get to them as soon as I possibly can. As always, I appreciate the support, and I will see y'all next time.